Hi guys, this is Trigonometry. It's spring 2020, but doesn't really matter the semester of the year. Trigonometry hasn't really changed in a couple hundred centuries, or a couple centuries. This is on writing. This is section 8.5. And what we're doing is we're looking at writing trig values in complex form. So let's take a look at the complex plane. The complex plane, the x-axis is for real values. The y-axis is for the imaginary component. Maybe I should say real component. So this is x, it's for real. This is y, and it's for the I values, the imaginary values. Okay. Let's look at two vectors in vector form. Let's put some hashtags in here so we can make it look right. That spacing isn't all that great, but let's say this is to right there. In the normal form of vectors, we would say that's 4, 3. In complex form, this is 4 plus 3i. Not I hat, just I. So this is in vector form. Complex value in vector form. Let's say that's my vector u. I got another vector v. Let's make it this is going to 5, negative 2, or 5 minus 2i. So the left and right values are the real component. And the up and down values are the complex or imaginary component. And this is for complex numbers in the form z equals a plus bi. We looked at resultant vectors. Resultant vector is when we added these vectors. So here I want to go 4 more right and up 3. My resultant vector is right there. This is resultant vector u plus v. And if we add those components, we have 4 plus 3i, and we're adding 5 minus 2i, and we get 9 plus i. So we, just like complex numbers that we've looked at in algebra, we add the real components and imaginary components separately. Okay. let's get this going over to trig. This was just a reminder of complex values and how they work and writing them in vector form. Let's take a look at the trig section of it. So recall we had cosine theta equals x over r. Sine theta equals y over r, which means we can write x equals r cosine theta, y equals r sine theta. If we square these, we get x squared equals r squared cosine squared theta. Y squared equals r squared sine squared theta. And what happens if I add these? X squared plus y squared equals r squared cosine squared theta plus r squared sine squared theta. We can factor out an r squared. Leaves behind cosine squared theta plus sine squared theta. But what does that equal? We know that value. That equals 1. We get x squared plus y squared equals r squared. This should be a reminder. And so r equals the square root of x squared plus y squared. And we have tangent theta equals y over x. This is the non-complex reminder. This isn't complex. So this is just a reminder. Trig to polar coordinates. Or, I'm sorry, Cartesian to polar. On one side, we have x equals r cosine theta, y equals r sine theta. This is good if you have r and theta. And on the right side, we have r equals square root of x squared plus y squared. And tangent theta equals y over x. And this is good at you can find r and theta given x and y. So another way to think of that, if we start with r and theta, and we want to go to x and y, we'll use x equals r cosine theta, y equals r sine theta. If we start with x and y and we want to go to r and theta, we'll use r equals x squared plus y squared, square root of x squared plus y squared, and tangent theta equals y over x. This is going from polar to Cartesian. Rectangular is another name for it. And this is rectangular to polar. We'll look at doing polar graphing in 8.6. No, 8.7. Now, what about the complex stuff? How about complex to polar? So we have x comma yi, not a subscript, yi, and we're switching over to r and theta. Well, we know x equals r cosine theta, y equals r sine theta. So here we have x plus yi in vector form. Well, that's just r cosine theta plus r sine theta times I. And oftentimes they write the I in front. I am going to factor out the r. This is r cosine theta plus I sine theta. This is the polar form of a complex number. They abbreviate this x plus yi equals r cis theta, which means cis theta is a shortcut for cosine theta plus I sine theta. And it comes from those letters right there. Okay. So cis has been a term around for quite a while. Not in a form you may have heard of it before. And so that's, what's r though? Well, we had r squared cosine squared theta plus sine squared theta. R is just the radius. And when they say it's the magnitude of x plus yi. The name for this is modulus. And of course, we want 0 to be less than or equal to theta, less than 360. So let's practice shifting back and forth. Let's, in our first example, let's write 4 cosine of 240 degrees plus I sine of 240 degrees in rectangular form. What is cosine of 240? This takes us back to our unit circle info. 240 degrees is that angle right there, which gives it a reference angle of 60 degrees. Cosine of 60 degrees is 1/2. We're in quadrant 3 though. In quadrant 3, cosine of 60 would be negative. We got negative 1/2. And then I've got sine of 360. We're in quadrant 3 is going to be negative. Negative root 3 over 2, and that's times I. So writing it in the lingo we had before, 4 cis 240 degrees equals 4 times negative 1/2 is negative 2 plus 4 times negative root 3 over 2. I'm going to put the I in front of the radical just so it's not confused as being underneath. Okay. I guess I said rectangular form. I should relabel that. This is complex form. The graphs look the same, so it's really easy. The only thing that changes is the y-axis. Goes from a real value to an imaginary value. Let's take an example from, let's go from, I don't know, complex to polar. And this is a little more challenging. So what you want to do is you want to sketch it in the complex plane. This will give us our quadrant and thus sines, or helps with the angle. B, we're going to do r equals square root of x squared plus y squared. And C, find theta using tangent invert or tangent theta equals y over x. Okay. Pause it. Jot down what you need. Let's take a look at an example. So for A, let's go with root 3 over 2 minus 1/2 I. And we're going to write that in polar form. So what we want to do is we want to start off graphing that. X here is root 3 over 2. Y is negative 1/2. Should be down here. So we're looking at quadrant 4. We should have 270 is less than theta is less than 360. Or in radians, 3 pi over 2 is less than or equal to theta, less than or equal to 2 pi. So that gave us our quadrant. R is root 3 over 2 squared plus negative 1/2 squared. This pen is dying. Let me get another blue pen out for use in a second. Root 3 squared is 3. 2 squared is 4. This is 1/4. R equals the square root of 1. R equals 1. And I'll throw that pin away. It looks dead. And finally, tangent. So theta equals tangent inverse of y over x. Negative 1/2 over root 3 over 2, which is tangent inverse of negative 1 over root 3. Or another way of looking at this is tangent theta equals negative root 3 over 3. Where does that happen? This happens when theta has a reference angle of 30 degrees. Okay? So we're in quadrant 3 or 4. The reference angle is 30 degrees. My real angle, theta, goes all the way around. That means theta is 330 degrees. R is 1. We've got cosine of 330 degrees plus I sine 330 degrees. Or you can write that as cis 330 degrees. It can also help another way of thinking about it. X equaled root 3 over 2, but we know that's r cosine theta, and r equaled 1. Y equals negative 1/2, which is r sine theta, but r equals 1. So I have cosine theta equals root 3 over 2, sine theta equals negative 1/2. Both of these tell me theta hat is 30 degrees. The signs give me the quadrant. That's another clever way of looking at it, but it's only really helpful for when it's going to be on one of those unit circle angles. You're better off if you don't recognize something from the unit circle in the x and y components, just use r equals x squared plus y squared, the square root, and tangent theta equals y over x. Let me give you guys one to try. The complex value is negative 3i. So you want to graph this, figure out where it is, find r and theta. I'll assume you're pausing the video. If you paused it, what this really is 0 minus 3i. So x equals 0, y equals negative 3 in the complex plane. We are straight down negative 3. This is 0, negative 3. I don't even need tangent theta, do I? What's theta here? The picture gives theta right away as 270 degrees or 3 pi over 2. Kind of gives the radius pretty well too if you've gotten used to looking at it. Let's take a look at it though. R equals square root of x squared plus y squared. R equals the square root of 0 plus negative 3 squared, which is square root of 9. R equals 3. So our vector 0 minus 3i into Cartesian or polar coordinates is, we're doing r theta 3 pi over 2. Comparing that with 0, negative 3i, or the xyi form. And we'll look at how that really works when we get to 8.7, when we start graphing it. I had you try going that way. Let's have you try going the other way. So convert to polar. And we're going to start off with 4 plus I times 4 root 3. You want to write that as r theta. That's not going the other way. Let's still do the same type of thing, isn't it? Complex to polar, yeah. All right, so x is 4. The y value, which is our I value, is 4 root 3, which is a little longer than 4. If that's 4, 4 root 3 might be a little bit longer. We're looking at that. We're in quadrant 1. So we've got 0 is less than theta, less than 90. R, what's my x here? X equals 4, y equals 4 root 3. So r is the square root of 4 squared plus 4 root 3 squared. The square goes to each of them. 4 squared is 16, and we distribute the square to both the 4 and the root 3. This is 16 times 3 in there. If you work that out, that's the square root of 64, which is 8. So that's r. Tangent theta is y over x. 4 root 3 over 4 is root 3. Do we know tangent theta equal to root 3 in quadrant 1? Hopefully you've learned to memorize that. That's 60 degrees, right? Or pi over 3 in radians. So we've got 4 plus I 4 root 3. That turns into 8 60 degrees, or 8 pi over 3. And we'll look at graphing polar in 8.7. What about multiplying? We already showed adding and subtracting complex numbers. Let's hit the, what about multiplying complex numbers? Let's recap ourselves on that. So the product of complex numbers you just have to distribute or FOIL if you're familiar with that acronym. So we will, let's take a look at multiplying 1 plus I root 3 times negative 2 root 3 plus 2i. We start off with 1 times negative 2 root 3. That's our F, which stands for first. Outside is our O. 1 times 2i is 2i. I'll put this over here in a complex column. I is inside. I root 3 times negative 2 root 3. Root 3 times root 3 is 3, right? The square roots cancel out. Times negative 2 would be negative 6. This gets us down to negative 6i. That's the inside. And L is for last. I root 3 times 2I. That is 2 root 3 times I squared. What is I squared? I squared is -1. So this ends up being -2 root 3. And we can add up all the values. -2 root 3 and -2 root 3 is -4 root 3. 2I minus 6I is -4I. I made it in a little table format. You don't have to. You can just distribute. We've got -2 root 3 plus 2I minus 6I minus or plus 2 root 3 I squared, which turns into -1, and then combine like terms. What would this be in polar? Well, we're looking at -4 root 3 back, -4 down. We're in quadrant 3 for theta. R equals, can we just do that? Get close to this. I had the positive version of this in our last example. This ended up being 8 when you're done. Tangent theta is -4 over -4 root 3, which is 1 over root 3, which is root 3 over 3. That's a 30-degree reference angle, right? So theta equals 210, which means -4 root 3 minus 4I is 8 cis 210, or 8 cosine 210 plus 8I sine 210. Let's look at doing this the other way, though. Can we verify this another way? So we started off with, what did we start with? We started with 1 plus I root 3, -2 root 3 plus 2I. We're multiplying this. Okay? Let's convert to polar first. So what is this in polar? R equals square root of 1 squared plus root 3 squared which is square root of 4, which is 2. Tangent theta equals y over x, root 3 over 1. This is theta equals 60 degrees. So this turned into 2 cis 60. R equals square root of negative 2 root 3 squared plus 2 squared. This is 4 times 3 is 12, plus 4 is 16. Square root of 16 is 4. Negative 1 over root 3. This is in quadrant 3. This gives us a reference angle of 30 degrees. Not quadrant 3. X is negative, y is positive. That's quadrant 2. So theta hat is 30 degrees, which means theta is 150. And this turns into R is 4 cis 150. Okay. Does that equal 8 cis 210? Let's check it out. Let's multiply it out. So the 2 cis 60 is 2 times cosine of 60 degrees plus I sine of 60 degrees. And then I'm multiplying it by 4 cosine of 150 degrees plus sine of I sine of 150 degrees. I can do the 2 times 4 out front. That's 8. And then I got to do a lot of distributing. I've got cosine 60 times cosine 150. Then we do, that's first. Then we do outside. I cosine 60 sine of 150. Then we do inside. I cosine of 150 sine of 60, keeping the order the same. And finally, the last ones, we have I times I is I squared. Sine of 60 sine of 150. That's a plus. So what do we have here? This turns into -1. So let's put the real components together. We've got 8 cosine 60 cosine 150 minus sine 60 sine of 150. That's our real component. And our imaginary component, I've got cosine 60 sine of 150 plus cosine 150 sine of 60. And this is our imaginary component. Does this look like a formula we know? Isn't cosine of A plus B equal to cosine A cosine B minus sine A sine B? I've got cosine cosine minus sine sine, different angles, but this is A is 60, B is 150. This just turns into 8 cosine of 60 plus 150, which is 8 cosine 210. That's getting us where we want to go, isn't it? If this last one equals 8 I sine of 210, we're golden. This is cosine A sine B plus cosine B sine A. That's sine of A plus B. A is 60, B is 150. This turns into 8I sine of 60 plus 150, which is 8I sine of 210. And adding the real and imaginary, which is 8 cis 210. There's a shortcut for this. I was showing you that how it works. In general, the shortcut is shortcut. So if we start off with RA time, so we've got two vectors, vector A and vector B. So I've got RA times cosine of A plus I sine of A times our second vector in polar form. This equals RA times RB. Multiply the two radiuses together. And then we have cosine of A plus B plus I sine of A plus B. Okay? Which boils down to RA times RB cis A plus B. Okay? Let's see applying this, the shortcut. Find the product of 4 cis 12 and 3 cis 18. So this says we've got 4 cosine 12 plus I sine 12 times 3 cosine 18 plus I sine 18. This is my RA. This is my RB. This is angle A. This is angle B. Following the pattern, I get RA times RB cosine of A plus B plus I sine of A plus B. Plugging in what we've got. RA is 4, RB is 3. I'm doing cosine of 12 plus 18 degrees plus I sine 12 plus 18 degrees, which is 12 cosine of 30 plus 12I sine of 30, or 12 cis 30. Doesn't make much sense to stop with cosine 30 and sine 30 though, does it? We actually know what those values are. This is 6 root 3 plus 6i. All right, that was multiplication. Let's look at doing a quotient. So let's talk about quotient or division in complex first. So this is our refresher on complex division. Let's use how many pages ago did this start on? We're going to use these vectors again, but let's make them division. So remember, when we do this, we multiply by the complex conjugate of the bottom. Of denominator. Which means just change the sign of the imaginary term. This thing right here is a plus b times a minus b. In algebra, that's a squared minus b squared. We can speed up the bottom. So the top let's multiply that out. We FOIL it. We've got negative 2 root 3 minus 2i minus 6i minus 2i squared root 3. This I squared is negative 1, and it'll make that a positive. So negative 2 root 3 plus 2 root 3 is 0. And negative 2i minus 6i is negative 8i, or just negative 8i. And I'll spell that out a little bit better. 2i squared root 3 is 2 times negative 1 times root 3. But we already had a negative out front. So 2 root 3. The bottom a squared minus b squared. A is negative 2 root 3. B is 2i. So I've got negative 2 root 3 squared minus 2i squared. This is 4 times 3 minus 4i squared. But I squared is negative 1. This should be 16. So 1 plus I root 3 over negative 2 root 3 plus 2i equals our top, which was negative 8i, over the bottom, which was 16. And this is just negative 1/2 I. Now let's do the same problem and convert to trig form first and see if this speeds up. Because doing multiplication or division with complex numbers just gets a little tedious. Is the trig form any better? So trig form of the same problem. We have 1 plus I root 3 over negative 2 root 3 plus 2i. If you go back in your notes or recalculate them, this was 2 cis 60 and this was 4 cis 150. And I know this should equal negative 1/2 I. Cosine theta plus I sine theta. Actually, yeah. So what is this giving me here? Let's think about what do we got here? Can we do anything with this? How does this relate to the 60 and the 150? This ends up being, this is like 1/2 times 0 minus I, right? Yeah, let's put the minus back inside. So I have to compare cosine theta equals 0 and I sine theta equals negative I. What angle does that happen at? Well, this top one, theta is either 90 degrees or 270 degrees. If I want sine of theta to equal negative 1, that has to be the 270 degrees. So theta equals 270 degrees. How does that relate to 60 and 150? We've got theta equals 270 degrees. That's either going 270 that way or negative 90 this way. Negative 90 though, that's 60 degrees minus 150 degrees, which is what we started off with. And the 2 over 4 is the 1/2, right? So what does this boil down to? We had 2 cis 60 over 4 cis 150, 1/2 of cosine of negative 90 degrees plus I sine of negative 90 degrees, which is our negative 1/2 I. The shortcut formula, if you can't tell, this was our first radius, our second radius, first angle, second angle. We have RA cis A over RB cis B. This equals RA over RB cis of A minus B. Does that work with what I just said? Let's do it on another page. Two cis 60 over 4 cis 150 equals 2 over 4 cis of 60 minus 150, which is 1/2 cis negative 90. And that is indeed negative 1/2 I. So let me give you one to try. We're going to use that formula still. Find 12 cis negative 30 degrees over 4 cis 120 degrees. Okay. Well, RA is 12. RB is 4. Angle A is negative 30 degrees. Angle B is 120 degrees. RA cis A over RB cis B. RA over RB cis A minus B. In R values, 12 over 4 cosine of negative 30 degrees minus 120 degrees, which is 3 cis negative 150 degrees. Or if we want to deal with a positive angle, that's 3 cis 210. Do we know those values though? 3 cosine 210 plus I sine, or 3I sine of 210. What's my reference angle there? Theta hat is 30 degrees. We're in quadrant 3, both are negative. Cosine of 30 degrees is root 3 over 2. This is negative root 3 over 2. And then I've got 3I sine of 30 degrees is 1/2, but we're negative because we're in quadrant 3. This is negative 3 root 3 over 2 minus 3/2 I. Let me give you one more to try. Your turn. Let's do, let's do 28 cis 150 divided by 7 cis 30. This turns into 28 over 7. I'm assuming you paused it. Times cis of 150 minus 30. which is 4 cis 120. That makes theta hat 60 degrees. What is cosine of 60? It's 1/2. We're in quadrant 2 though, so that's negative 1/2. Sine of 120 is the same as sine of 60. They're both positive, √3/2. And we get -2 plus 2i √3. That'll wrap up 8.5. And I hope you enjoy it. You're not going to use it so much for quite a while, actually. But I am going to test you on this stuff. Because this is a trig course. Peace. We're almost done. Hang in there.